Hello Math Geniuses, and welcome to another math lesson with Miss Q. Today's lesson is all about negative exponents, and what I would like for you to do now is pause the video and make sure you have all the materials you need. Paper and a pencil and possibly a calculator. Do that now. Fantastic. Alright, so our standard is the same standard we've been working on, that is 8EE1, which is all about the properties of exponents. So the first thing I'm going to do for the mini lesson is I'm going to review the properties of exponents that we have already learned. There is product of powers property, which is when you keep the base and add the exponents because you're multiplying exponential expressions. And here's an example of that. So if I had 2 to the third power times 2 to the fourth power, I would keep my base because they're the same, and I would add my exponents. So 2 to the third power times 2 to the fourth power is 2 to the seventh power. That is the product of powers property. Alright, we also learned about the quotient of powers property. Quotient of powers property says when you are dividing exponential expressions with the same base, you keep that base and subtract the exponents. So I'm going to do an example here. Let's say I had 2 to the fifth power divided by 2 to the fourth power. 2 to the fifth divided by 2 to the fourth, I would keep that same base of 2 and subtract the exponents. And that becomes 2 to the 5 minus 4 power, which is 2 to the first power, which I could just write as 2. And we also have the power of a power property. Alright, so that says when you are raising an exponential expression to another power, you keep the base and you multiply the exponents. So a to the m raised to the n power would be a to the m times n power. And here's an example of that. So if I have 2 to the fourth power raised to the sixth power, I would keep that base of 2 and I would multiply these exponents. So that becomes 2 to the 4 times 6th power, which is equal to 2 to the 24th power. And lastly, we also learned about the zeroth exponent. Any number raised to the power of 0 is equal to 1. No matter the base, no matter what it is, if it is raised to the 0th power, it is equivalent to 1. Alright, and in this blank is where we are going to write our new exponent rule. Negative exponents. First, write this. So with a negative exponent, you want to be able to rewrite this with a positive exponent. And the way you do that is you keep the base, alright, but you're going to flip it. You keep the base and take the reciprocal. So a becomes 1 over a. And then you change the sign of the exponent from negative to positive. Alright, so I like to say keep, change, flip, because a lot of you already have that in your mind. So keep, change, flip, what do you keep? The base. Change the sign, and what do you flip? The number. So what I would like for you to do right now is copy this into your notes and pause the video and take a look at the steps very quickly before I do this activity on the right. On the right side, I'm going to show you why this rule works. I'm going to zoom in. So here we have 2 to the third power. 2 to the third power is 8. 2 to the second power is 4. 2 to the first power is 2. And 2 to the 0th power is 1, because anything raised to the 0th power is 1. And as you can see, we are dividing by 2 every single time we go down a row. So to continue on that pattern, I'm going to divide 1 by 2 and that gives me 1/2. I'm going to divide 1/2 by 2, and that gives me 1/4. And I'm going to divide 1/4 by 2, and that gives me 1/8. When you compare the 2 to the third with its negative exponent counterpart, 2 to the negative third, you'll see that it goes from 8 to negative, not to negative 8, to 1/8, right? If you compare 2 to the second to its negative exponent counterpart, it goes from 4 to 1/4. Alright, and you can go ahead and compare 2 to the first to its negative exponent counterpart, and you'll see the same pattern. Alright, so no matter what, when you have a negative exponent, all you have to do is keep the base, change the sign of the exponent, add that to your notes, and flip the number. Alright, here are the I2 questions. The direction simply says simplify the expressions. And because we're working with negative exponents today, we want to keep in mind that we want to turn those negative exponents into positive exponents. So, my first step for the first question, which says 3 to the negative 8th power times 3 to the 6th power, is I want to simplify using the properties of exponents I've already learned. This is a multiplication problem, so I'm going to be using the product of powers property. I'm going to keep the base, and I'm going to add the exponents. So negative 8 plus 6. So I get 3 to the negative 2nd power, and what I want to do is I want to rewrite this expression as an equivalent expression with a positive exponent. So the equivalent expression with the positive exponent is what I'm going to use my negative exponent property to create. I'm going to keep the base, change the sign of the exponent, and flip the number. So it becomes 1/3 to the 2nd power. And if I wanted to simplify that further, that would be 1/9. Alright, second question, I have d to the negative 4th power divided by d to the 2nd power. And this is division. So I'm going to use the quotient of powers property, which tells me to keep the base and subtract the exponents. So keeping the base as d, subtracting negative 4 minus 2, that gives me d to the negative 6th power. Alright, and again, I'm going to do the same thing, rewrite this as an equivalent expression with a positive exponent by keeping the base, changing the sign of the exponent, and flipping or taking the reciprocal of the number. I want to simplify first. So I'm going to first work with the top, but then I'm going to work with the bottom. So on top I have g to the 3rd power raised to the negative 2nd power. I'm going to take the power of a power property, keep that base, and multiply those exponents. So I'm going to get g to the negative 6th power. And on the bottom, I'm just going to move the terms with the common base closer to each other. So that's a to the 4th power times 8 to the negative 6 is multiplication. So I'm going to keep the base and add the exponents. And that gives me a to the negative 2nd power. Alright, so now I have a to the negative 2nd power times g on the bottom. I'm going to rewrite that. And this g by itself, remember when we have a term by itself with no exponent, that exponent is 1. So now I want to simplify this because there is more simplification to do. So the way I'm going to do that is I'm going to separate this term into two fractions that are being multiplied by each other. In one fraction I'm going to have all the a terms, and in the other fraction I'm going to have all the g terms. doing this allows me to focus on just one term at a time. So I can look here and focus on the a term, and I see I have 1 over a to the negative second power. And if I want to rewrite this with a positive exponent, I'm following the same rules. I'm keeping the base. The base here is a. I'm going to flip it, so instead of 1 over a, it's now going to become a over 1, which is simply just a, and I'm going to change the sign of the exponent. So 1 over a to the negative second is equivalent to a to the second. And on this side, with g as my common base, I still have some simplifying to do here. Alright, so g to the negative 6th power divided by g to the 1st power, keeping the base, subtracting the exponents, gives me g to the negative 7th power. And a negative exponent I must rewrite with a positive exponent. So g to the negative 7th power is equivalent to 1 over g to the 7th power. Alright, so I'm going to bring down my a term. Now I have a to the 2nd power times 1 over g to the 7th power, and I can multiply straight across and get a to the 2nd power over g to the 7th power. And that is my final answer. Right, so I can't simplify this anymore because a and g are not the same base, so this isn't going to become a over g to the negative 5th or anything like that. No, this stays just as it is. This is as simplified as it gets. Here is the redo problems. I want you to pause the video right now and try these on your own. And then once you're done trying them, you can see how I work them out.